Hey guys, Mr. Roach again. It is Wednesday, March 25th, 2020, and we are still on our force and motion unit. Let's go over our bell work for today. Identify three ecosystems that are not aquatic. Identify three ecosystems that are not aquatic. Breaking down the question, so we need to find an ecosystem that is not aquatic. That aquatic word means, a root word for the aquatic is our aqua, which means water biomes. So we're trying to find three biomes that are not water. Okay, so let's go ahead and list our three water biomes and then let's take everything else past that. So we know that we have a marine biome, which is also the ocean. So either the ocean or salt water biome. We also have a freshwater biome. So your creeks, your streams, your lake, your rivers, those are your freshwater biomes. And then we have that in between where the salt water and the freshwater comes together. It makes the estuary. All right, saltwater, freshwater, they meet. We create the estuary biome. All right, so those are the three main water biomes. So we have anything else that is not a water biome would be that can be listed here. So we have our deserts, we have our tundras, we have our tropical rainforests, we have our temperate rainforest or deciduous forest, we have our grasslands. So any of those five could go into the three that are not aquatic: grasslands, tundra, deserts, tropical rainforests, temperate rainforests, and grasslands. Question number 2. The force necessary to keep planets in orbit around the sun is A. Gravity, B. Friction, C. Magnetism, or D. Nuclear. All right. The force necessary to keep planets in orbit around the sun. Which one do you guys want to pick? What I want you guys to do, say the answer super loud at home. We have a special guest inside the house. Miss Barnhart is actually going to say the answer super loud out here. She's going to scream. She's going to scream. Gravity, yes. The force necessary to keep planets around the orbit around the sun is gravity, right? So remember, Earth is smaller than the sun, so the sun gravitational pull makes the Earth circle around the sun. All right, today we're going to focus on motion in our force and motion unit. All right, so motion is the movement of an object, the movement of an object. So Monday we saw where we were with Miss Flint and Miss Alston, and I, using force, pushed Miss Flint out the way. All right, she moved to a different location, so her movement was straight. I pushed her at a different direction or a different position. All right, so when an object moves when an unbalanced force acts upon that object. I was an unbalanced force that acted upon Miss Flint, and I pushed her out the way. So a motion could be an unbalanced force that is either a push or a pull. If we're looking at our screen and we see the grown-up trying to push the car in that direction, so he's trying to push the car in the direction he wants to go, and we see the other young boy pulling the wagon in that direction. They're moving the object either with a push or a pull. So that will move the object, creating motion. All right, the motion of an object is described with respect to some other object or position. So basically, all that's saying is that it's moving in a different direction. So you can either move it straight, so that is a different direction. You can move it to the right. You can move it to the left. It can fall down to the ground, and the position will be on the ground. So just the position that the object is going. So a car is going straight. All right, that's the description of the object in its position. Key thing we have to talk about is the distance. All right, so distance is going to be how far the object is moving. far it's moving. So if the distance is 34 feet, right? We just finished off our measurements in math. So if we threw an object 34 feet, let's say Ashley A was so mad at Mr. Roach, she picked up my keys and threw my keys 34 feet. All right. She was so upset that she threw it 34 feet. All right. That's how far I went, was the 34 feet. Speed. How fast is the object moving? Okay. As you guys can see on the screen right now, we can see that the runners are running really fast. So the time that it takes them to get to one position to another position, that's how fast they were going. It took the runners 9.10 seconds to cross the line. But how fast the object is going. All right. So knowing a distance and knowing the time, so it took them 9.10 seconds for the runners to cross the line, we can figure out the speed, right? And this is something that you're going to need to know for that EOG testing towards the end of the school year. You're going to need to know that speed equals distance over time. Typically, whenever you guys see this question on the EOG, it's going to give you that conversion or it's going to give you that formula anyway. But you still need to have it in the back of your mind that, hey, I have the distance, I have the time, so now I can figure out the speed. Okay, so we're going to have a couple problems to go through to figure that out. A car takes 3 hours to travel 180 miles at a constant speed. How fast is a car traveling? We get the formula. Speed equals distance over time. So the main thing that we have to focus on in this question is figuring out which is our distance and which is our time. We know time is a variable of, it can be seconds, it can be minutes, it can be hours. So when you're trying to find that time factor, you're trying to look for minutes, you're trying to look for seconds, or you're trying to look for hours. That's your time indication. Distance is going to be miles, it's going to be feet, it's going to be inches. All right, those are your indications for the distance. Those are the words you're looking for in that. So reading the question again, the car travels 3 hours to travel 180 miles at a constant speed. How fast was the car going? All right, we do know speed equals distance over time. Okay, so we're going to assume, we're not going to assume because we know, because we're smart and we figured it out. We know that speed equals distance over time. All right, so we know that the distance is 180 because it says miles. So we're just going to assume that that's the distance. So we're going to put 180 over, what are we going to put on the bottom? What's that indication of time? 3, Mr. Roach? Absolutely. All right. We know from math that every fraction is a division problem. Okay. So to figure out this answer, we're going to do the denominator into the numerator. So we're going to do 180 divided by 3. 3 times what is going to get us as close as possible to 180. All right. Or just think about it. 3 times what is going to get us as close as possible to 18. 6, Mr. Roach? Correct. 6. 3 times 6 gives us 18. Bring down your 0. 3 goes into 0 0 times. Add your 0 up top. Your 0. You're done. So we know that the car went 60 miles per hour, right? 3 hours being the time, 180 being the distance. Using our formula to plug all that number in and then dividing the denominator into numerator to get our answer, all right? The second question. Michelle. Shut up, Michelle. Michelle drove 300 miles in 6 hours. What is Michelle's speed? All right, again, we get that formula. Speed equals distance over time. All right, first thing we need to figure out, what is the distance being indicated? Michelle drove 300 miles in 6 hours. what is Michelle's speed? All right, so what is the distance? What is the distance in this question? Distance would be 300 miles. All right, knowing our formula again, we know that speed equals distance over time. We know that Michelle drove 300 miles and took her 6 hours. 6 hours being that time going on the bottom. Okay, so we're going to do the denominator into the numerator. So we're going to have 6 divided by 300 divided by 6. I'm sorry, guys. All right, 6 goes into 6 times what is going to just as close as possible to 300. We can break it down like this. 6 goes into 30 how many times? 5. Yes, thank you, Miss Barnhart. 6 goes into 30 5 times. 6 times 5 gives you your 30. 0. Bring down your 0. 6 goes into 0 how many times? 0. Yes, Miss Barnhart. All right. 6 goes into 0 0 times. All right. So 50 miles per hour would be your answer. All right. So that's the 2 problems that we're going to do today. So what you guys need to do now, pop off this video, go ahead and head to Discovery Ed, go ahead and do your assigned Discovery Ed lessons for your independent practice. When you're doing Discovery Ed, please make sure you guys are doing the activities inside the reading, explore, and engage. When you get done with your reading, please make sure you mark everything off as completed on Discovery Ed so we can give you credit for today. That's one way that we keep knowing that you guys are actively trying your e-learning experience. When you get done with reading Discovery Ed, please head back to Google Classroom and do your exit ticket for today. Submit the exit ticket so we can get credit for that. All right. Just another way that we know you guys are actually doing the work and learning. All right. You guys have a good day. And I will see you guys during office hours.